Today we're going to talk about polynomial long division. And the thing about polynomial long division is that we need to have some idea of how to long divide in the first place. So our first example that we're going to look at is we're going to divide the following without a calculator using long division. We want to write the remainder in simplest fraction form. So first of all, we need to be able to set up this problem. What we're going to do is we're going to take 951 and we're going to divide by 7. When we do long division without a calculator, which you might not have done since 5th grade, we ask ourselves, how many times does 7 go into 9? Well, 7 goes into 9 one time. So we're going to put a 1 above the 9. And then we take 1 times 7, and that's 7. And we subtract that value. 9 minus 7 is 2. Conceivably, your elementary teacher who taught this then drew an arrow, brought down the 5. Then we do the same process again. How many times does 7 go into 25? Well, 7 times 3 is as close as we're going to get. 3 times 7 is 21. And we subtract. Well, 25 minus 21 is 4. And again, I think that your elementary teacher drew an arrow and brought down the 1. So we go through this process one more time. 41 essentially divided by 7. Well, 41 divided by 7 is 5. It's not an even number. 5 times 7 is 35. And we subtract that. 41 minus 35, 6. And what your elementary teacher might have done that I don't care for is that he or she might have gone, okay, R6, remainder 6. But if we look back at the directions say to write this in simplest fraction form. What we do in algebra now is we write 6 sevenths. It's whatever remainder is divided by our divisor, which happens to be 7. What we're dividing by in the first place. So in this particular problem, is 7 a factor of 951? No. And it's not, because there is a remainder. There's something left in the end. But what we're dealing with here, when we factor a polynomial, we're trying to find factors of the polynomial that give the quotient, the other factor, and a remainder, which your elementary teacher sometimes called R. But this suggests that being able to divide one polynomial by another polynomial can help you factor polynomials, which is where we're kind of going with this. We hope that the remainder is 0, because if the remainder is 0, then we have found a factor. But we'll look at that as we go through these notes here in a couple minutes. But in polynomial long division, we need to make sure to write the terms in order of degree. In other words, we need to write the polynomials in standard form. highest degree first, then next highest degree, then next highest degree, and so forth. But again, especially to people who are watching the video, you might not understand the first example. And you might not understand the second example. But hopefully, as we get to the third and the fourth example, it will start to make sense. But here's our steps here. Use polynomial long division to divide 4x squared plus 23x minus 16 by x plus 5. We want to find the quotient, and we want to find the remainder. The quotient is an answer to a division problem, and the remainder we may or may not have one. But the process is off to the left side of the smartboard here, and the first step says that we're going to take our highest degree term, which is 4x squared, and we're going to divide it by our variable out here.
Thank you.
Going to divide it by the variable out here in our divisor. So in other words, we're going to take 4x squared, and we're going to divide it by x. And when we do that, if you can't do that in your head, this is just 4xx divided by x. And one of the x's cancels out. So our first value that's going to go up as part of our quotient is going to be 4x. And if you think about what we did up there on our first example with just numbers, we multiply. 4x times x is 4x squared. 4x times 5 is 20x. It was positive 4x times positive 5. Change both signs. There's the subtraction. Subtract to get 3x. Well, where's that 3x coming from? Well, 4x squared minus 4x squared is 0. It cancels out. And that's what we're trying to do. We're trying to get rid of the highest degree term. And then we have 23x plus a negative 20x, which gives us 3x. And then we're going to carry down 16 minus 16. And we're going to repeat that process. So now our highest degree term is 3x. We're going to divide that by x, which is coming from our divisor of x plus 5. And the x's cancel out. So 3x divided by x is 3. Those are both positive numbers. Positive 3x divided by positive x is positive 3. And now we're going to take that value. 3 times x is 3x. 3 times 5 is 15. It was positive 3 times positive 5. Change both signs. And when we do, 3x minus 3x is 0. It cancels out. Negative 16 plus a negative 15 is negative 31. That is our remainder, but we don't want to just write r there. We want to write the polynomial, the remainder in simplest fraction form. So this last part's going to be that it's minus 31, and then our denominator is going to be x plus 5. The quotient is what's on top there. 4x plus 3 minus 31 divided by x plus 5. And our remainder, as we see, is the negative 31. Again, for some of you that might make sense. on the first try, but it won't surprise me if that doesn't make sense yet. Give it a little bit more time. The factor theorem says that the expression x minus a is a factor of the polynomial if and only if the value a is a zero of the related polynomial function. Well, that's a jumble of words that people are going, well, I'm not even listening to what you're saying. But what I'm saying here is, if we get a remainder of 0, in other words, if we don't have a remainder, then what we're dividing by is a factor. And if we get some number, like we just got negative 31 for remainder, then that means what we divided by is not a factor. So in the above example, x plus 5, it does not, oh my gosh, it does not divide the polynomial, 4x squared plus 23x minus 16. Therefore, x plus 5 is not a factor, and x equals negative 5 is not a root. Well, where did I get that negative 5? Oh, come on. Where did I get the negative 5? Well, negative 5 came from taking x plus 5 equals 0, and then we subtracted 5 from both sides. So x equals negative 5. That's where it came from. One more time I want to say it. If our remainder is something other than 0, what we're dividing by is not a factor. If we end up with 0 when we finish the problem, no remainder, then what we divided by will be a factor. So as we flip over our paper here, we're going to go through that process again. I'm going to make this a little bit bigger. When we start this problem, do notice that our dividend, x cubed plus 2x squared minus 5x plus 12, is in standard form. It's highest exponent, then next highest, then next highest, and so forth. As well as what we're dividing by, the x plus 4, sometimes called the divisor. And what we're going to do is we're going to try to get rid of the highest degree term every single time. So when we start this, our highest degree term is x cubed. We are going to divide by x. We're using the variables to simplify this polynomial, so to speak. X cubed is x times x times x. And here's x. One of those x's cancels out. We get x squared, and that's what's going to go on top here as part of our quotient. To figure out what eventually we're going to subtract, we take x squared times x, which is x cubed, and we take x squared times 4, which is 4x squared. Change both signs. And what we accomplish when we change both signs is the highest degree term better cancel out. X cubed minus x cubed cancels out. And we're left with 2 plus a negative 4 x squared gives us negative 2 x squared. Bring down the 5x. including its sign, which is minus 5x. Repeat the process. We're going to take the highest degree term. In this case, now it's negative 2x squared. And we're going to divide by x. If you need to, this is negative 2xx divided by x. And what happens is that one of those x's cancels out. And we're left with negative 2x, which is what's going to be part of our quotient, our answer to our division problem. Negative 2x times x is negative 2x squared. Negative 2x times 4 is negative 8x. Change both signs. When we change both signs, negative 2x squared and positive 2x squared cancel out. We're left with negative 5x plus 8x, which is 3x. And we're going to bring down the 12. And we go through that same process. We're repeating the process again. We want to get rid of the highest degree term. Our highest degree term this time is 3x. And divide by x. The x's cancel out. And we're just left with 3. It's positive 3x divided by positive x, which is positive 3. Three times x is 3x. 3 times 4 is 12. Change both signs. And when we do, the 3x's cancel out. But also what happens is we have 12 minus 12. That cancels out also. And we have no remainder on this problem. And when we have 0 as our remainder, so to speak, is our divisor a factor? Yes. The quotient on this problem. Quotient means answer to division problem is x squared minus 2x plus 3. Our remainder, we don't have one. And again, when we do not have a remainder, then the divisor, what we divided by, the x plus 4, is a factor, and we can find a root of the polynomial. So if we look at the next example, 4x to the fourth minus 5x squared plus 2x plus 4 divided by 2x minus 1. We need to watch out. We are missing a cubed term in this particular problem. So when we set this up, because not only are we missing the cubed term, we also have to set this up. We need to put in a value for our cubed term. So it's going to be 4x to the fourth. We're missing the cubed term. So I usually write plus 0x cubed. There's nothing wrong with writing minus 0x cubed, but you want a place marker in there. So 0 times x cubed is still 0. So we're not adding anything in except for a place marker. Then it's minus 5x squared plus 2x plus 4. We are dividing by 2x minus 1. And the 2x minus 1 is the divisor, and that's eventually what we're going to ask ourselves. Is the divisor a factor? Do we have a remainder? Do we not have a remainder? Is ultimately what we're looking at. So now that we get the problem set up, and again, if it's missing a term, we need to fill in a 0 there. But the process is still going to be the same. We want to get rid of the highest degree term. So our highest degree term to start here is 4x to the 4th divided by 2x. We're using the variables in this problem. 4x to the 4th, the first value underneath our division bar, and the 2x, the value that has the variable in it in the divisor. 4 divided by 2 is 2, and my space isn't very good, but x to the 4th is x divided by x. One of those x's cancels out, and we get x cubed. So our first value in our quotient is going to be 2x cubed. So we're going to use it. We're going to multiply. 2x cubed times 2x is 4x to the 4th. 2x cubed times negative 1 is negative 2x cubed. Change both signs. When we change both signs, 4x to the 4th is going to cancel out. Positive 4x to the 4th, negative 4x to the 4th. And then we get 0 plus 2x cubed is 2x cubed. I want to switch colors there, but it's still going to be 2x cubed. Bring down to minus 5x squared. I'll switch. Don't add the exponents. Just add or subtract the numbers in front. Good question. Good question. So now, we want to get rid of the highest degree term. So our highest degree term is 2x cubed. And we're going to divide by 2x. Well, 2 divided by 2 is 1. And then we have x cubed, which is worst comes to worst. If you don't know your exponent rules, then that's going to work for you. X divided by x gives us x squared. And that's going to be our next value up here. It's going to be plus x squared because it was positive 2x cubed divided by positive 2x. We're going to multiply. X squared times 2x is 2x cubed. X squared times negative 1 is minus 1x squared. Change both signs. When we change both signs, 2x cubes are going to cancel out. One's positive, one's negative. They're opposites of each other. And then we have negative 5x squared plus 1x squared, which is negative 4x squared. And we're going to bring down our next term, which is going to be the plus 2x. So we want to get rid of the highest degree term. Negative 4x squared divided by 2x. And negative 4 divided by 2 is negative 2. X squared is x times x divided by x. One of the x's cancels out. So we get negative 2x, which is going to be part of our quotient. Answer to the division problem. I'm going to use that value now. Negative 2x times positive 2x is negative 4x squared. Negative 2x times negative 1 is positive 2x. Change both signs. What happens here is that negative 4x squared cancels out with the positive 4x squared, but 2x plus a negative 2x also cancels out. So I hesitate to write the 0 here, but everything cancels out there. Don't forget, we still have a 4. Can we divide 4 by 2x? No, one's got a variable and one doesn't. This 4 ends up to be our remainder. If you did write down the 0, it would be 0 plus 4, and 0 plus 4 is still 4. So our remainder up here is going to be plus 4 divided by 2x minus 1, coming from the divisor. Is our divisor a factor? No, because we ended up with 4 and not 0, it is a no. Going to pause the video for a second. So as I jump into the practice here for one more example, 2x cubed minus x squared plus 5x minus 12. We need to set it up. We get 2x cubed minus x squared plus 5x minus 12. We're dividing by 2x minus 3. And we're always trying to get rid of the highest degree term. So we're going to take 2x cubed. We're going to divide it by 2x. And 2 divided by 2 is 1. X cubed divided by x. It's x divided by x. So when we cancel out one of our x's, we're going to get x squared. We're going to use that value. X squared times 2x is 2x cubed. X squared times negative 3 is negative 3x squared. Change both signs. But I also need to at least warn you to be careful. Sometimes people mess up. Not here. 2x cubed minus 2x cubed still cancels out. Sometimes people forget that there's a 1 in front of that x squared term. So this is negative 1x squared plus 3x squared, which is 2x squared. Bring down the 5x. So it's going to be plus 5x. And now we need to go through the process again. We need to get rid of the highest degree term, which is going to be done by taking 2x squared divided by 2x. And once again, 2 divided by 2 is 1. And then we have x squared divided by x. The x's cancel out. It's positive 2x squared divided by positive 2x, which means that this is going to be plus x. I'm going to use that value. X times 2x is 2x squared. X times negative 3 is negative 3x. Change both signs. Once again, what happens is that our 2x squareds cancel out. And we have 5x plus 3x, which is 8x. And as we go back and look at the problem, do we need to bring anything else down? And sure enough, we still have a minus 12. But we want to get rid of the highest degree term. Our highest degree term now is 8x divided by the 2x. The x's cancel out, and 8 divided by 2 is 4. It's positive 8x divided by positive 2x, which is positive 4. And 4 times 2x is 8x. 4 times negative 3 is negative 12. Change both signs. What happens is that not only do the 8x's cancel out, but we have negative 12 and positive 12. They also cancel out. In other words, we get nothing left. So then the question becomes, is 2x minus 3 a factor? And the answer is yes.